Hi everyone. Today we're going to talk about some flow proofs. And um, so make sure you have some paper. We're going to write these out and let's just jump into this. Now, the first thing we need to do is to take all the given information and to put it into the picture. Okay, so CA is perpendicular to AD. So CA is perpendicular AD. So let's go ahead and put that right angle mark in there. Now it looks like my pen is going to spaz out again today. CB is congruent to BA, and CA is perpendicular to CE. Okay, now the final goal of this entire thing is to prove that this side here is equal to this side here. Now we'll get there. Now, first thing we need to do is we need to prove these two triangles are congruent, and we're going to do that with 3 steps. Now, the way we do this is no longer a T-chart proof. This is a flow proof. There's always 3 steps. We need to decide how we're going to prove them congruent. So we have several ways to do that. Excuse me. We have SSS, SAS, ASA, and we need to choose from one of those. Now, as soon as you look at the picture, I see some like hidden information. I see that technically I have some vertical angles in here, and we know that vertical angles are always congruent. So I can go ahead and put that within my diagram. So now, what type of situation do we have? We have an angle, we have a side, we have an angle. And on the other triangle, you have an angle, you have a side, and you have an angle. So you're going to prove this by ASA. Now, as we do this, you don't have to go in this order, but this is a good method for a beginning flow proof student, just to prove things in that order: an angle, and then the side, and then the angle. Again, it doesn't really matter what order you do it in, as long as you have all 3 steps. So if you accidentally do AAS or SAA, it's fine. Just have all the information there. Now, let's start with the easy one, the vertical angles. Now, I can't just say angle B and angle B. I have to use 3 letters to avoid confusion. And I know that B is my vertex, so it's CBE is equal to angle DBA. Now, here's the weird thing. You're going to put a box around this. And underneath it, you're going to tell me how you know it. Now, this was not given information. We know this because of a theorem. And this is one of the mostly used theorems that we have. And this is theorem 6. So underneath, write theorem 6. Now, let's do a side. And if I need to, kind of reorganize this a little bit to give myself more room, that's fine. So it's not all crunched together. My sides, how did I know these? Well, that was up here in the given. So that one's easy. So I'm just going to rewrite this given information. CB is equal to BA, if my pen will work. And I'm going to put a box around it. And underneath, I'm going to say given. All right, now here's how you know when you're finished with each step. Once you prove that something is equal to something else, then you're finished. Notice in step 1, I said the 2 angles are equal, finished. In step 2, I said the 2 segments are equal. I'm finished with that step. Now, it's going to be a little different for this last one. Now, I'm going to use these 2 givens, And if you notice, it doesn't tell you anything is congruent. It tells you that they're perpendicular. Now, we know some stuff about perpendicular lines, and so we're going to have to make additional conclusions. Now, you have a choice. You can just write it out like this and put and, or you could like stack them maybe to save room and say CA is perpendicular to CE and get rid of that. And we'll put a box around all of it and say given. Hopefully I have room. Okay, now again, I'm not finished with this step. Look at your theorem and postulate sheet, and let me grab mine. We know things about perpendicular lines. Perpendicular lines form a certain type of angle. What kind of angle is that? Of course, it's a right angle. And how do we know perpendicular lines form right angles? So look at your sheet and find the theorem that tells you that. And that is Theorem 7, which says perpendicular lines form right angles. Now, just because it's a right angle doesn't mean we know it's 90 degrees yet. Okay, so don't jump ahead. We can say, where's the right angles? Angle C is a right angle, and angle A is a right angle. All right, that's what we know, and hopefully you can read that. So again, this is Theorem 7, because perpendicular lines form right angles. Okay, so what do we know about right angles? Look at your theorem sheet. We know something about right angles. Right angles are always, the E word, equal. Okay, so we're going to say that angle C is equal to angle A. Put a box around it. And the reasoning is, did you find it yet? Corollary to the definition of right angles. And my pen just fell apart a little bit. It's probably why it's not behaving. All right, let's see if it works better now. Now, guys, we're finished with step 3 because we noticed something. Do you see that equal? Oh, the pen's not working any better. It is equal. So we're finished with this step. We just proved how these two angles are equal to each other. Okay, now we're not finished. Now that you proved the 3 things, now we can bring them all together. So it's like pipes. We're going to bring all of them together, and we're going to write a big congruency statement. Now, order matters. The first triangle you can write in any order that you like. So I'm going to do the left triangle, and I get to choose the order. Let's go BCE. BCE. Now, this is the only time that the person that wrote your textbook will use the congruent symbol. Okay, so please use your congruent symbol. And now the order of the second triangle matters, okay? So you have to go in corresponding order. So what corresponds with angle B on the second triangle? And of course, that's B. C corresponds with, what's the other right angle? That would be A. And E corresponds with D. Now, again, you could have changed the order of the first triangle, but the order of the second triangle is dependent on the first triangle. I hope that makes sense. Now, underneath it, we're going to say how we just proved this. Now, we have this several places on our paper. So right there, I wrote it, ASA. I wrote it up here, and I wrote it over here on this side. So underneath it, don't forget, underneath every box, you have to say how they're congruent. This is ASA. Now, if you look, we did not prove what we set out to prove. Okay, now stick with me here. if two triangles are congruent, that means technically there are three sides that are corresponding and congruent, and there are three angles that are corresponding and congruent. But we only had to prove three things total. But there are really 6 parts that are congruent. So there's 3 parts on the triangle that I haven't even talked about. So for instance, this side here, not talked about it, but there's a part over here that is corresponding and congruent. The same thing with this angle, and this side, and this side. So what we're going to do is we're going to say if the triangles are congruent, then those parts we really haven't talked about yet are technically equal to each other. We just haven't talked about them. So it's one additional little step. It comes out of the congruency statement, and it's what you're proving. CE is equal to AD. Now let's look at the picture. CE and AD. Those are corresponding and they are congruent. Now, see this big long statement up here? Corresponding parts of congruent triangles are equal. Think about what we're saying here. Are these two pieces corresponding? Yes. Are they congruent because they're on congruent triangles? Yes. Therefore, they have to be congruent. No one wants to write this out. So we abbreviate it. And they're all capital letters, CPCTE. Okay? And I will ask you on a quiz or something later, what are the 5 letters and what do they stand for at the end of a flow proof? And this is what I'm talking about. So we're finished. This is one whole entire flow proof. You just proved how to make the two triangles similar, or make the triangles congruent with each other. There we go. Now we're just going to do a couple. I think there are 3, 4. Okay. Oh, there's several. All right. So let's just jump into the next one, pick up the speed a little bit. You'll see they're all pretty much the same. You just have to plug in the information and go from there. D is the midpoint of AC. So that means these two little segments are congruent. I know that BD is perpendicular to AC, so let's draw on the right angle. This is all I know. I know there are going to be 3 steps. 2 things are given on the diagram, so I need to look for something that's hidden. Now, I see that this segment BD is part of the left triangle and part of the right triangle. So it's not going to change size. So when I'm looking at segment BD, it's the same length as when it's on the left triangle as when it's on the right triangle. So it's called being reflexive. Remember that from before? When a segment is equal to itself, BD is equal to BD. So we have to mark that. I call that hidden information. We have to include that so we can determine how they're congruent to each other. So we have a side, we have this angle, and we have the side. So we are going to prove this by side, angle, side. And remember, these don't necessarily have to be in this order, but I always do them that order just to help out. So let's start with the easiest, honestly, let's start with the reflexive side. That's the easiest one. Both triangles share segment BD. So I'm going to write BD is equal to BD, put a box around it, and say that this is reflexive property. Now I'm finished with this step because I already showed what it was equal. Now we have to go to the given information next. Now for the angle, how did I know this was a right angle? Well, they told me it was perpendicular. And we did this on the last example. So BD is perpendicular to AC, and we're going to draw a box around it and say that it's given. So we're going to go in the same order as we did on the previous one. So perpendicular lines form right angles. Now I'm going to call this angle 1 and angle 2 just to make life easier. Angle 1 is a right angle, and angle 2 is a right angle. So I'm going to box it up. And again, how do I know they're right angles? because of Theorem 7. Theorem 7 says perpendicular lines form right angles. Now I'm not finished because I don't show that they're equal yet. Now I'm going to say angle 1 is equal to angle 2 because the corollary to the definition of right angles says all right angles are equal. Come on, pen. Corollary to definition of right angles. I think my pen's dying, guys. Oh, it's messy. I hope you can read that. Now, lastly, how did I know this little side AD? Well, I can't just write AD is equal to DC because it's not written that way in the given. I have to use the way it's written in the givens, which is D is the, come on, pen, midpoint of AC. Box it up, given. Now, we're not finished because nothing is shown as being equal yet. But we know the definition of midpoint. Midpoint means it's the point in the middle that divides and makes two equal parts. So AD is equal to DC. Box it up. And what definition did we just use? Definition of midpoint. Now we have two things that are equal, so we're finished with step 3. But we're not finished with the proof. Now, I'm kind of running out of room. We'll make it work. We're going to bring all 3 steps together and write a congruency statement. Remember, the first triangle could be in any order that you like. And I'm going to say, since it's my choice, ADB. Again, this needs to be a congruent symbol. It's the only time in the entire book we will use a congruent symbol. And then make sure everything corresponds. So A corresponds with C, D with D, and B with B. Now underneath, make sure you tell me how, tell me how you know they're congruent. And hopefully you have it over here on the side, which I'm trying to highlight and it's really not working. It's SAS. Now we have one more step. Come on, pen. SAS. There it goes. We need to prove that the two angles are equal. So somewhere, it could be above, it could be below. I know I ran out of room going horizontally. I'm just going to make a little branch and say these two angles are equal. And it's our little magic letters because no one wants to write it out. CPCTE. Corresponding parts of congruent triangles are equal. And we're finished. This is a complete flow proof. All right, same picture, different information given. This time I know angle 1 and angle 2 are congruent. And I know ABD, so this one way up here is congruent to CBD. Okay, now I'm only given 2 things, but I need 3, so look for something that's hidden. And it's the same thing that we had before. We have this side here in the middle. And that was called being reflexive. So look and see what we have. Do we have 2 sides and an angle, or 2 angles and a side? And hopefully you're saying we have an angle, a side, and an angle. So this is angle, side, angle. Okay, again, you can go in any order that you want. I'm going to go ASA, and let's just prove one of the angles. And actually, both of them were just given, so that's easy. Let's just write them out. Angle 1 is equal to angle 2. Box it up, given. And we're finished because we just showed why they're equal. And while I'm at it, let's just do the other angle. ABD is equal to CBD. Box it up, given. How did I know the side? Well, just like before, BD is equal to BD because it's reflexive. The length of BD does not change from the left triangle to the right triangle. This is reflexive property. So guys, this was a super short and sweet one. We're finished with all three steps. We're going to bring all three together and write your congruency statement. Remember, the order of the first one matters. So A, D, B, make sure it's a congruent symbol. C, I think I just wrote that wrong. Come on, pen. Oh, big crash. All right. Let me see if I can get this back. It is. All right, woo, that was a close one. All right, A, DB is congruent to CDB. And hopefully you know how we just proved it. Look over here. We proved this by ASA. And we have one more branch to do. Now let's look at it. Is this side here corresponding and congruent to this side? And of course they are. So make sure again you know what the 5 letters stand for. Come on, pen. This is frustrating. All right, C, P, C, T, E. And we are finished. All right, we have 2 more to go. Thanks for hanging in with me. All right, I really like this picture. We keep using the same picture over and over. Let's plug in this information. BD bisects the angle, so that means it's going through and it's making these 2 angles congruent. I want to put 2 little slashes there. And again, we have a reflexive side. Notice how I put 1 slash, 2 slashes, and 3 slashes, so there's no confusion. You know exactly what corresponds with what. So we need to decide how we're going to prove these. Angle, angle, side, side, angle, side, angle, side, angle. You know, we just have to figure this out. So we have a side, we have an angle, and then we have a side. So this is a case of SAS. All right, so here's a side that was given to me. So let's just go ahead and write that in. And box it up and say given. Now we're finished with the step because it says it's equal. For the next one, the angle. Well, this is the angle. Now before I knew these 2 were equal, I had to know my given. So BD bisects angle ABC. Okay, let's box it up. Say given, but we're not finished because it doesn't show anything that's equal. Because we understand the word bisect, bisect means it cuts it into 2. Let's name the 2 congruent angles. So let's go back up here to the diagram. Remember, the vertex has to be the middle letter. So A, B, D is equal to C, B, D. Box it up. And I only know this because I know this vocab word, which is definition of bisector. Now we're finished with this step because now I know what's equal. And my computer is not happy today. It likes proofs less than you guys. Ha ha, it's a joke. Okay, now, last step. and that is the reflexive side, which we've already had a couple times already. BD is equal to BD, box it up, and this is reflexive property. All right, so I'm going to bring all three steps together. Oh my goodness, it does hate us today. Let's get through this proof, please. All right, let's bring it together. All right, guys. I think it's about time to call it quit on notes. Okay, let's just talk this out since it's not cooperating. All right, so you're going to bring these together. You're going to write a congruency statement. Hopefully you know how to do that. Same picture that we've had several times. And then the branch off of that is going to say angle 1 is equal to angle 2 because that's what we're trying to prove. And then you're going to put the 5 letters underneath it, C, P, C, T, E. Whew, never had so much trouble making a video. Okay, so I'm not going to attempt this one since my computer's not working. Please try it. And I can post a picture of the answer if you would like, or join a help session. I'm happy to help you. And let me know if you guys have any questions or concerns. Thanks.